And now I would like to introduce Team Hacker Planner. They are one of the winners in this year's Keelung Hackathon. So, Mr. Jheng, the floor is yours.
Okay, hi everyone. Thank you for your introduction and inviting me here. It is my pleasure to join this meeting. And today I will introduce our hackathon project, Track Transformation, the intersection of AI and Keelung data. And before we start, here is a little bit about our members' introduction. We are from Sinotech Engineering Consulting Company. I am Dechain, and Jeffrey and Benson are here. Our expertise including urban planning, industrial park design, and also spatial data analysis. And talking about spatial data analysis, nowadays, we are living in a golden era of Earth observation, EO. And basically, we are able to get the global Earth observation data from various possible sources. And a lot of data are being provided openly, free, and with long-term perspective. So in this project, we are trying to propose a new framework for spatial planning that using Earth observation data, open data, and AI. And our research area located in Keelung River Corridor, which including 6 urban planning areas, is lie across the boundary of Keelung City and New Taipei City. So how do we envision the site? In order to seek out the spatial issues and the potential of our study area, we using the text mining technology to dig out the official reports, including spatial plan or as-per-meeting minutes. The result shows that in the urban planning sector, put a lot of effort into discussing about location, industry, transportation, and conservation. Therefore, our task force on strategies for industrial transformation. And we need to understand the spatial development, industrial potential, and the transportation accessibility. Meanwhile, we want to share our thoughts on ecological and digital governance. How do we observe changes in spatial development? Here is a 50 years long-term satellite image in Keelung River Corridor. Here we can see the early development centered in downtown Keelung, and then gradual sprawl along the Keelung River Corridor. But how to further the quantitative analysis? We can using the artificial intelligence and the Earth observation technology to observe the spatial changes. First of all, we need to collect the satellite data of our study area. Then we prepare the train data set. We split the data for 60% for training and 40% for validation. Then we reshape the data and continue the normalization. Next, we adopt the deep learning model, which is a multi-layer perceptron. Then we tune the hyperparameter to reduce the overfitting problems. Then we check the accuracy and predict. In other words, we are able to turn this kind of satellite imagery to this kind of building footprint, and our accuracy are over 95%. So first part, let's see the spatial development in Keelung. Here we can analyze the development ratio change over time. In 2000, the development rate is around 70%, and in 2010, it goes up to 84%. And currently is around 88%. So we can analyze the proportion of development in this way. Next, we can overlay the building map. Here is a spatial development in 20 years. The dark yellow indicates the development is more recent. So we can use this data to identify where the urban development located. Besides, we can compare it with the industrial park to understand where the growth goes faster and where it's slower. The second part is industrial potential. In order to understand which location has higher potential, we observe various big data, including manufacturers, population, land use, etc. So first, we examine the factory growth. In 2010, the growth rate is around 20%. And in 2015 is around 25%, and currently is over 30%. So we can see manufacturers grow rapidly over the past 5 years, and new factories are clustering in the river corridor. Besides, we also found that traditional and technology industry are the dominant and primary industries, and is congregated in early built industry park, which could be the priorities for industry transformation. Here is our industrial potential map. The dark orange indicates the higher potential. In the past, there was a lack of correlation between industrial data and the built environment. So it is important for us to build a bridge between these two and provide a different perspective for future economic growth. Next is transportation accessibility in Keelung. In order to understand the connectivity of the street network, we using the spacing test method. We also want to know the distance to public transit. We perform the service area analysis. Here is our third outcome. This is a transportation accessibility map. The yellow area indicates the better accessibility. Here, we could use this map to help us to formulate industrial strategies. Next, after a series of analysis, we are trying to combine spatial development, industrial potential, and transportation accessibility. In other words, we try to connect the data analysis to development strategies. In this map, here you can see 3 types of area. The red area is high suitability area. It can play the leading role in industrial development. For example, the technology industry could be further developed in this area. And the green area is a high industrial potential area, where it's less accessible but attractive for industry. So less place could be suited for traditional industry. And next is blue area, where is high accessibility area, which is nearby transportation infrastructure and with high connectivity of the street network. For example, it would be the proper location to develop the logistic industry. So after talking about industry development, how to find a balance between economy and conservation. Here in the fourth part, we using the satellite image to understand vegetation changes. We can calculate the RVI ratio, which is a vegetation index. We calculate 2000, 2010, and 2021. Here is our outcome. We can identify the vegetation change types. Here we can see 3 types of vegetation change, including loss, no change, and better. So the government can make ecological conservation for the lost area. Therefore, we can propose our digital governance platform. First of all, the government can invest the industrial need for the private users. Then the government can provide industrial strategies like we propose. But how government to review the development? Here, we can use the AI and EO technology to check the development and adjust the strategies. On the other hand, the government can release the ecological conservation location where can be adopted by the industry users. For example, if someone wants to build an industrial park, then they need to do some restoration for the environment, like to plant some trees in vegetation loss area. And how does the government review the conservation? We can using the satellite image analysis to check the conservation. So both public and private sector could benefit from this model. To sum up, in this project, we are trying to propose a new framework for spatial planning. We're using text mining technology to seek out key issues and using the Earth observation and the AI technology to understand urban growth and vegetation change. And we also using social and industrial big data to identify the industrial potential. Then we conclude some industrial development strategies and connect it with the digital governance platform. So at the end of the day, we hope to provide a new insight for city planning, and dream that we can reimagine urban with brilliant data. Thank you.
Thank you very much, Mr. Jheng, and to Team Hacker Planner. If there's any question that you have in your mind regarding Taiwan's related project or proposal that the team just mentioned, please don't be shy and just type it up in the call note.